Welcome to today's class.
Today we are going to look at these three amazing formulas you can apply in solving calculations on radioactivity. We are expecting questions on radioactivity in the forthcoming exam. So these formulas, I'm going to show you how to apply it to solve three questions. It came out in 3 different years. We are going to tackle the questions. The first is the disintegrating ratio R is equal to N naught over N. We are taking this one as the initial mass or number of atoms. The initial mass or initial number of atoms. We are taking this N as the final mass or number of atoms. The final number of atoms is equal to 2 raised to power N, where N is the number of half-life, and this N, which is the number of half-life, is equal to T over capital T, where small letter t is the time taken for decay and T is the half-life of the radioactive element. Okay, if you need to write down all this, you can screenshot it or write it down. The disintegrating ratio R is equal to N naught over N, which is equal to 2N, where N naught is the initial mass of the atom, N is the final mass or the number of atoms, N is the small letter N is the number of half-life, T is the time half-life of radioactive element, and small letter t is the time taken for decay. So with these formulas in mind, let's look at this first question. A radioactive isotope has a half-life of 8 days. What fraction of the atom will remain after 72 days? To solve this, let's write out all that we are giving, then we'll apply the formula. A radioactive isotope has a half-life of 8 days, giving half-life of 8 days. So we'll write T as 8 days. What fraction of the atom will remain after 72 days? It then means that time taken for decay, T, is equal to 72 days. So which formula are we going to apply? Remember that R is equal to initial mass over final mass, and is also equal to 2 raised to power N. And remember that 2 raised to power N is equal to 2 raised to power T over the half-life. So let's move on and solve for what fraction of the atom will remain after 72 days. So fraction that will remain after 72 days will be 1 over the disintegrating ratio, which is 1 over 2 raised to power. The fraction that will remain will be 1 over R, which is 1 over 2 raised to power N. 2 raised to power N is 2 raised to power T over capital T. Our small letter t is 72. That's time taken to decay over the time at half-life, which is 8. That will give us 2 raised to power 9. So we'll go on and get the fraction that will remain will be 1 over 2 raised to power 9, which is 1 over 512. So this is the final answer. The second question, an element whose half-life is 10 days is of mass 12 grams. Calculate the time during which 11.25 grams of the element would have decayed. Let's write out all the parameters we are given. An element of half-life 10 days, giving the half-life T to be 10 days, is of mass 12 grams. So let's say N naught, the initial mass, is 12 grams. Calculate the time during which, so we are looking for T, small letter t. Calculate the time during which 11.25 grams of the element would have decayed. Okay, let's write out all the parameters. Giving t to be 10 days, n naught is 12 gram, t, that's the time we are looking for. ND is 11.125. So the number that remained will be the original minus the number that decayed. 12 minus 11.25, we'll have it as 0.75. So this is the number that would have remained. So let's now apply the disintegrating factor. Remember, that's the most important. R is equal to n naught over n, which is 2 raised to power n. This formula is very, very important. So our n naught is 12 over n is 0.75 is equal to 2 raised to power. Remember, n is t over the half-life. That's t over 10. We'll go ahead and solve this to have that 12 over 0.75 will give us 16 is equal to 2 raised to power t over 10. So let's go on and reduce this as 2 raised to power 4 is equal to 2 raised to power t over 10. With that, we can, the bases are equal to 2, so we have that 4 is equal to t over 10. This will give us the final answer, which we are looking for t as 4 times 10, and that is 40 days. That will be the answer. For question 3, a radioactive substance has a half-life of 3 minutes. After 9 minutes, the count rate was observed to be 200. What was the count rate at 0 time? So let's write out all the parameters that we are given. Solution. Then giving a radioactive substance has a half-life of 3 minutes. So we can use the half-life as 3 minutes. After 9 minutes, that's time taken to decay, small letter t. After 9 minutes, the count rate was observed to be 200. That means after 9 minutes, the fraction remaining n was found to be 200. Okay, what was the count rate at 0? So the initial one is what we are looking for. Remember the formula we are to apply, that R is equal to n naught over n, which is 2 raised to power n. Okay, with this we can go ahead. We want to find the initial count rate. We'll go on and solve and have it that n naught over n is 200 is equal to 2. Remember, n is small letter t over capital letter T, which is 9 over 3. So n naught over 200 will give us 2, 3 here 1, 3 here 3, 3 raised to power 3. So if we cross multiply, we'll have our n naught to be 2 raised to power 3 times 200. 2 raised to power 3, that will give us 8 times 200. So that the final answer will be 1600. Hope you enjoyed this video. Please give this video a thumbs up and don't forget to subscribe to this channel. See you in the next class. Thank you.